California Electrical Code (SEC) mandates arc fault circuit interrupter (AFCI) protection for receptacles installed in walk-in closets that are fully enclosed with a door. This requirement is based on the National Electrical Code (NEC), which serves as the foundation for the CEC. The NEC mandates AFCI protection for all 15 amp and 20 amp branch circuits that supply outlets or devices installed in dwelling units. This includes walk-in closets to enhance electrical safety and mitigate the risk of electrical fires. AFCI breakers are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Unlike traditional circuit breakers that primarily respond to overloads and short circuits, AFCIs are sensitive to the unique characteristics of arc faults. An arc fault occurs when electricity jumps, or arcs, between two conductors, creating heat and potentially igniting nearby flammable materials. There are two primary types of arc faults: series arc faults and parallel arc faults. Series arc faults occur when there is a break or degradation in a single conductor, causing the current to arc across the gap. Parallel arc faults occur when there is a short circuit between two conductors with different potentials, such as a hot wire and a neutral wire, or a hot wire and a ground wire. AFCIs are designed to detect both types of arc faults. The NEC Article 210.12 specifies the requirements for AFCI protection in dwelling units. It outlines the specific locations where AFCI protection is required, including bedrooms, living rooms, family rooms, dining rooms, kitchens, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. The requirement for AFCI protection in closets is intended to address the increased risk of arc faults due to the presence of flammable materials such as clothing, linens, and storage items. These materials can easily be ignited by an arc fault, leading to a fire. When an AFCI detects an arc fault, it quickly trips the circuit breaker, interrupting the flow of electricity and preventing the arc fault from escalating into a fire. The AFCI breaker continuously monitors the electrical current flowing through the circuit, looking for patterns and characteristics that are indicative of an arc fault. These characteristics include rapid fluctuations in current, high-frequency noise, and distorted waveforms. When the AFCI detects these characteristics, it triggers the internal tripping mechanism, which opens the circuit and stops the flow of electricity. There are two main types of AFCI breakers: branch/feeder AFCIs and outlet branch circuit AFCIs. Branch/feeder AFCIs are installed in the electrical panel and provide protection for the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet on the branch circuit and provide protection for the remainder of the circuit downstream from that outlet. In most cases, branch/feeder AFCIs are used to provide AFCI protection for entire branch circuits, including the wiring and all outlets and devices connected to the circuit. However, outlet branch circuit AFCIs can be used in situations where it is not feasible to install a branch/feeder AFCI, such as in older homes where the wiring may not be compatible with branch/feeder AFCIs. When installing AFCI breakers, it is important to follow the manufacturer's instructions and all applicable electrical codes. The AFCI breaker should be properly sized for the circuit and should be installed in a location that is readily accessible. It is also important to test the AFCI breaker after installation to ensure that it is functioning properly. This can be done by pressing the test button on the AFCI breaker, which should cause the breaker to trip. If the breaker does not trip when the test button is pressed, it may be defective and should be replaced. In addition to the requirements for AFCI protection in dwelling units, the NEC also includes requirements for ground fault circuit interrupter (GFCI) protection in certain locations. GFCIs are designed to protect people from electrical shock by detecting ground faults, which occur when electricity flows through an unintended path to ground. GFCIs are required in locations where there is a high risk of electrical shock, such as bathrooms, kitchens, garages, and outdoor areas. While AFCIs and GFCIs both provide important electrical safety protection, they are designed to address different types of electrical hazards. AFCIs protect against arc faults, which can cause fires, while GFCIs protect against ground faults, which can cause electrical shock. In some cases, both AFCI and GFCI protection may be required in the same location. For example, a receptacle in a bathroom may require both AFCI and GFCI protection to provide comprehensive electrical safety. The California Electrical Code adopts and amends the NEC, so it is essential to consult the latest edition of the CEC for the specific requirements in California. The local jurisdictions may also have additional requirements or amendments to the CEC, so it is important to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. In summary, the requirement for AFCI protection for receptacles in walk-in closets in California is intended to enhance electrical safety and reduce the risk of electrical fires. By detecting arc faults and quickly interrupting the flow of electricity, AFCI breakers can prevent fires from starting and protect people and property from harm. Adherence to the California Electrical Code and the National Electrical Code is crucial for ensuring that electrical installations are safe and compliant with industry standards. When dealing with electrical installations and modifications, it is always recommended to consult a licensed electrician to ensure that the work is performed safely and in accordance with all applicable codes and regulations. A licensed electrician has the knowledge, skills, and experience to properly install and maintain electrical systems and to identify and address potential electrical hazards. Ignoring or circumventing electrical codes and safety requirements can have serious consequences, including electrical fires, electrical shock, and property damage. Therefore, it is essential to prioritize electrical safety and to seek professional assistance when necessary. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and published by the National Fire Protection Association (NFPA) and is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It is widely adopted by state and local jurisdictions as the basis for their electrical codes. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Chapter 1 covers general requirements such as definitions, wiring planning, and examination and approval of equipment. Chapter 2 covers wiring and protection, including topics such as wiring methods, conductor ampacity, overcurrent protection, and grounding. Chapter 3 covers wiring methods and materials, including requirements for different types of cables, raceways, and enclosures. Chapter 4 covers equipment for general use, including requirements for appliances, luminaires, and motors. Chapter 5 covers special occupancies, including requirements for hazardous locations, healthcare facilities, and places of assembly. Chapter 6 covers special equipment, including requirements for electric signs, electric vehicles, and renewable energy systems. Chapter 7 covers special conditions, including requirements for emergency systems, fire alarm systems, and communication systems. Chapter 8 covers communications systems, including requirements for telephone, data, and cable television systems. Chapter 9 contains tables and examples to assist in the application of the NEC. The NEC is a complex and detailed document, and it is essential for electricians, electrical engineers, and other professionals involved in electrical installations to have a thorough understanding of its requirements. The NEC is not a design manual, but rather a set of minimum safety standards. Electrical installations should be designed and installed by qualified professionals who are knowledgeable about the NEC and other applicable codes and standards. The NEC is constantly evolving to keep pace with advancements in electrical technology and safety practices. It is important to stay up to date with the latest edition of the NEC and any local amendments to ensure that electrical installations are safe and compliant. In addition to the NEC, there are other codes and standards that may apply to electrical installations, such as the National Electrical Safety Code, NESC, which covers electrical power and communication lines, and the International Building Code, IBC, which includes requirements for electrical systems in buildings. It is important to be aware of all applicable codes and standards and to ensure that electrical installations comply with all requirements. When working with electricity, it is essential to follow safe work practices and to use appropriate personal protective equipment, PPE, such as gloves, eye protection, and insulated tools. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock, burns, and other injuries. Before working on any electrical equipment, it is important to de-energize the circuit and to verify that it is de-energized using a voltage tester. Lockout/tagout procedures should be followed to prevent the circuit from being accidentally re-energized while work is being performed. Only qualified and trained personnel should perform electrical work. Electrical work should never be attempted by someone who is not familiar with electrical safety practices and procedures. In summary, electrical safety is paramount, and compliance with the National Electrical Code and other applicable codes and standards is essential for ensuring that electrical installations are safe and reliable. The California Electrical Code, as mentioned, is based on the National Electrical Code, but it includes amendments and additions specific to the state of California. These modifications are made to address unique conditions and requirements within California, such as seismic activity, environmental factors, and specific state laws. The CEC is updated on a regular cycle to align with the latest edition of the NEC and to incorporate any necessary changes or additions. One of the key areas where the CEC may differ from the NEC is in the adoption and implementation of energy efficiency standards. California has a long history of promoting energy efficiency, and the CEC often includes more stringent requirements for energy-efficient lighting, appliances, and building systems than the NEC. These requirements are designed to reduce energy consumption and to promote sustainable building practices. Another area where the CEC may differ from the NEC is in the requirements for renewable energy systems. California has a goal of increasing the use of renewable energy sources, and the CEC includes provisions to facilitate the installation and integration of solar photovoltaic (PV) systems, wind turbines, and other renewable energy technologies. These provisions may include streamlined permitting processes, interconnection standards, and incentives for renewable energy projects. The CEC also addresses specific issues related to electrical safety in California, such as the requirements for surge protection devices, SPDs, in areas prone to lightning strikes and the requirements for ground fault protection in agricultural buildings. These requirements are tailored to the unique environmental and operational conditions in California. It is important for electricians, contractors, and building owners in California to be familiar with the CEC and any local amendments to ensure that electrical installations comply with all applicable requirements. The CEC is available for download from the California Building Standards Commission website, and it is also available in print from various publishers. Local jurisdictions in California may also have their own electrical codes and regulations that are more restrictive than the CEC. It is important to check with the local building department to determine the specific requirements in a particular area. In addition to the CEC, there are other codes and standards that may apply to electrical installations in California, such as the California Green Building Standards Code (CAL Green), which includes requirements for energy efficiency, water conservation, and indoor environmental quality. CAL Green applies to new construction and major renovations of residential and non-residential buildings in California. The California Energy Code, also known as Title 24, Part 6, establishes energy efficiency standards for residential and non-residential buildings. The Energy Code covers a wide range of building components and systems, including lighting, HVAC, water heating, and building envelope. Compliance with the Energy Code is mandatory for all new construction and major renovations in California. The California Fire Code, CFC, includes requirements for fire safety in buildings, including fire alarm systems, fire sprinkler systems, and fire-resistant construction. The CFC is based on the International Fire Code, IFC, but it includes amendments and additions specific to California. Compliance with the CFC is essential for ensuring the safety of building occupants and preventing fire damage. In summary, The California Electrical Code is a comprehensive set of standards and guidelines for electrical installations in California. It is based on the National Electrical Code but includes amendments and additions specific to the state. Compliance with the CC and other applicable codes and standards is essential for ensuring the safety and reliability of electrical systems in California. Remember to always consult with a licensed electrician to ensure safe and compliant electrical work.